Images in Worksheets is another of our top 10 picks for Vectorworks 2013, and with this feature you are now able to create an image of any item that is being listed in a worksheet. So here, for example, is a door schedule, and I've got a little preview of each of the doors here. Here is a plant list. I've got a preview of each of the icons that we used in the drawing to represent these particular plants, and here a list of lighting devices with the preview of what each of those looks like. Let's have a closer look at one of these. We'll go to our Worksheets menu and open this one, and here you can see that we've got the plants being listed here. And I'll turn on database headers, and then we can just have a quicker look at the settings that you can use to control these. Firstly, the formula you'll see is very simple. It's just equals image. That's all you need to type into here. Or if you just have a blank, if you have nothing here, you can just choose the option to insert image function, and that will put that text up there. So if we format this, we'll just go ahead and accept that change. If we choose Format Cells and we look at this new tab here, which is called Images, you'll see here that we can set the image type to thumbnail or 2D attributes. And with 2D attributes, you can create a legend of hatches or wall types or gradients or something like that. So in other words, pick up the 2D attributes that an object that was listed in the worksheet used. In this case we're using thumbnails, and we can set the size here either as a fixed size or to use the layer scale that the object was placed on, or via a custom scale. We can also set the margin to whatever we want, and if the object happens to be a 3D object, then you can also set the view to any of the standard views, for example right isometric. When you do that, you can then choose the render mode to be either wireframe, OpenGL or hidden line. And this sort of combination is really good for furniture and things like that, because you can create a list of furniture items that you might want to give to your client or something like that, and you'll get a nice little right isometric view rendered in OpenGL of each of the pieces of furniture here, assuming they're 3D. So some very nice options, I think, in being able to present the images in Worksheets now. Align, distribute, lead align. This is one of those little improvements that is just going to take the drudgery out of some of the things that you used to have to do. Quite frequently you'll end up with a whole lot of drawing notes or call-outs that need to be aligned, or plants, or existing trees, or stake objects, or any other object that has a leader line. And previously, to align these, you would have to select them and possibly draw a guideline and then individually manipulate each one to get them nicely lined up and or spread evenly. Well, no longer. Let's take a look at this. So if we select these callouts here and we go up to Modify, Align, you'll see this new menu command here, Align, Distribute, Leader Lines. And here we can align the shoulder points and align and or the label points, and we can also set a vertical distribution. Let's just look at the first options to begin with. So we click OK and then just draw the line that we want to use, and this can be a line at any angle, but we'll go with a vertical line here, and you'll see that these all get aligned up nicely. Now let's do that again. Modify, Align, Align, Distribute, Lead Lines, and this time we'll set it to create equal distance between the shoulder lines. So click OK, and we'll move these in a little bit, and you'll see that this time we've got an equal distance between these points here. So let's try it with the plants. So again, align, and we'll go with parallel target lines this time. Click OK, and we'll do it at a slight angle, and you'll see this way we've got the parallel lines. Now, because this plant here was directly in line with that one, obviously we've got an issue with those parallel lines. So you may want to do that again, which is fine. We can go here and perhaps choose the equal distance instead. Click OK, and ultimately you can get the kind of result you want, and that's going to work for these other objects as well. I'll just quickly do this one. So I think something that ultimately when you're laying out the drawing and tidying things up, it's going to save a lot of time. Roof improvements. There have been some good changes in this area as well in Vectorworks 2013, both to the roof object and to roof faces. Let's begin by selecting these walls here and putting it to the test. So we've got a series of walls that just wouldn't work in Vectorworks or earlier versions of Vectorworks. So we'll go to AEC and create roof, and we'll go with all of these settings except that one. Click OK, and you'll see the roof was fairly successfully and instantly created, which is good to see. Render this up in OpenGL, and just to take it a little bit further, you'll see that I can then, in the usual way, go ahead here and add some further enhancements to the roof. And so on. So you'll see that it's a lot more reliable than it used to be. Now you've probably also noticed there's a roof face object here, and what's significant about this is that roof faces now support dormer windows and skylights. So you can see this is a roof face object, and here's a dormer window in it, and I can click on that and access the standard dormer window options, or for a skylight, the standard skylight options that were previously only available in roof objects like this. Another one of our top 10 features is the new surface array command, and this is well, something you're going to have to play with to appreciate. This command is able to array a series of 2D objects or a series of 3D objects across a 2D surface or a 3D surface that is curved. So I'm only going to give a very brief rundown of what it might do here, but let's go ahead and select this polygon and these rectangles here, and we're going to array these across this surface here. We go to the model menu to create surface array, and I've got a few options here, but let's just go with a 5x5 array to start with and click OK. And essentially these things have now been arrayed across that surface. So I can now look up here and control the number of repetitions. So I could increase this to 8, for example, in the X direction, and 3 in the Y direction. I can rotate the pattern. I can then choose the kind of trimming. So currently this is trimmed to the original polygon, but I could say to omit any of the ones that overlap the edges, or just allow them to overlap the edges as they were, or to trim them off. I can, let's go back to our original 5x5. I can increase the X factor, and this will, if this is greater than 1, it will create a gap between the objects. So if I set this to 1.1, I'll get a small gap in the X direction, and likewise I would in the Y direction as well. Then we have the shift factor, so I can shift one row to the next row. So I could put this in at 0.5, and the things will then shift around. So you can see that you can really experiment with how these patterns work and develop a lot of alternatives very quickly, whether this be for a design for a tiling pattern on a floor or a curtain wall or whatever. There are a lot of options just in using it in a 2D sense like this. For 3D, then it gets very interesting. Here we've got a few little 3D objects that I want to array across this surface. Let's take a look at what I've actually got here before we do this. So essentially here I've just got some extrude along path objects, and on top here I've got some mesh objects, these 4 mesh objects. These mesh objects are going to represent the glass of this object, and these other objects here will represent either a truss or a purlin. How is that possible, you say? Well, let's have a look. So we'll select these objects here and this curved surface, and just let me render that so you can see clearly what the surface is. So we'll go up to here and choose Create Surface Array, and here we'll go with 6 by 7, and let's click OK. And it's going to think for a moment, and you can see now that those things have been arrayed across the surface. I'm going to just turn off that base surface so we don't see that original curve that we created. Give that a moment to regenerate. So let's render this in OpenGL and see what we actually have here. So what's happened is that those objects have been arrayed across the surface here. So here are the purlins. The other pieces have created these trusses, and I can vary what happens with this now by varying those numbers. So let's go ahead and select this and change the number of Y repetitions to say 5, and that's going to affect the spacing of the trusses, and you can see now the trusses are spaced at wider centers, and so on. I can go on playing around with this. I mean, this is just a very simple example of how this might work, but it opens a lot of possibilities when you're designing or trying to work out and develop these complex systems. Auto Hybrid. This is a new kind of object in Vectorworks that allows you to develop 2D geometry from 3D objects. Let me explain a little bit about hybrid objects to start with. I guess the classic hybrid object is a door, and here is a door. In a plan view you want to see a line, maybe with a little bit more detail than that, and you want to see an arc like this. You really don't get any idea of what the object looks like in 3D. It might have some door hardware, it could have glass, it could have panels, whatever. And this applies to any number of objects like walls and floors and various symbols and things like that. In a 3D view, what you might want to see, is the frame and the glass panel, and if you rendered it, you want to see the hardware and so on. So you have this slight disconnect between the 2D component and the 3D component, and often you will have the 3D component having modeled that, but then you want to generate the 2D component, and that's what the auto hybrid will do. So looking at this 3D again, we have this what is it? Is it a drying rack? Is it an aerial? It's quite a large object, but it's useful to demonstrate this feature. Let's go ahead and select this, and we'll choose the auto hybrid command from the AEC menu. Here it is up here. And so what's happened? Well, what's happened is that it's automatically generated the 2D component. You can see at the cutting plane we've got the thicker lines with the dark grey fill. We then have a solid representation of the base, and then what's above the cutting plane has come through as dashed. All of this can be controlled, and if we select the object, you can see that there is cut plane up here. So let's move this up a little bit, say to 4 meters, and see what happens to our object. Well, the cutting plane has now moved all the way up to this point here. Let's knock that back a bit to say 3 meters, and now the cutting plane is down here, and this part is dashed above, and you have what is below. Now you can control via classes the attributes of what appears above, at the cutting plane, and below. Now let's have a look at that. We click the 2D Appearance button here, and at the cut plane we're using a class called Auto Hybrid Cut, so I can edit the attributes of that class to control the fill and the pen, or I can use the attributes of the original object, or I can turn off the fill. So that's at the cut plane. Below the cut plane we've got the fill set to none, but let's change it just to demonstrate, and we'll use the fill of the objects that made up the 3D component. And for the pen we'll leave that on the same. Above the cut plane we are using, we've chosen to display the objects above the cut plane, which you don't have to do, and we're using a class called Auto Hybrid above, and we're using those class attributes for both the fill and for the pen. Notice that you also have the ability to show as reflected ceiling plan, which can be quite useful for a hybrid object that is above what would be the normal cutting plane of 1 meter or so. So let's go ahead and click OK, and you'll see here that now the base has taken on those changed colors. These colors are coming from the 3D component. So this is the 2D representation of this, and if we switch to a 3D view we're going to see the same 3D representation. So let's have a look at another example here, and this is a curved wall. Again in 3D you can see the wall has a curve to it, and the front face has a batter or slope on it, and we want to correctly represent this in a top plan view, and currently we're just seeing this in a top plan view. We're in wireframe. We can kind of see more detail than we want to see. Essentially we want a cut that's about 1 meter or so through the object. So we select it, and we'll do the same again. We'll go to Create Auto Hybrid, and straight away what we've got here is the solid section through our wall, and that is again controlled by the cut plane. So you'll see if I reduce the cut plane to say 1 meter, this heavy grey fill area is going to get thicker. There it is, that's at 1 meter. Let's go back to 2 meters. We can see the dashed line that represents the top of the wall, and we can see this line here which represents the footprint of the wall. So there are many uses for an auto hybrid, particularly in the world of BIM or building information modeling, but being able to take a 3D model and automatically generate the 2D component, I think is a great new feature. The new Create Detail Viewport command automates the process of creating a detail viewport. In other words, enlarging some section of a 1 to 50 or 1 to 100 part of the plan and creating a larger detail of it, as we have in this example here, this little part here being exploded to create something more detailed. Let's have a look at how it works. You begin with outlining the area that you want to create the detail from, and with that selected, go to the View menu. You'll see a new option here, Create Detail Viewport. Let's go ahead and choose that, and here we can choose the layer it will go on. We have a sheet layer already set up called WD2 Details. Here we can set the drawing number, let's say it's 10, and the title, call it Wall Detail, and the scale that we want it at, let's say 1 to 10, and obviously we can control the classes and layers and so on. Here we can set the options, so we can choose the marker symbol, the shoulder length, the line weight, and the tag position. Let's put the tag off to the top left and click OK and OK, and here we are on the sheet layer. And here's our detail viewport. It's got the label that we gave it, it's got the number, the scale is automatically listed there, so with a couple of fine adjustments here in advanced properties, maybe increase the line weight scale and the hatch line scale, click OK, and we've got a reasonable looking section there. Now if we go back to the design layer, here we can see that we've got the label as we called it up, 10WD2, and if I change the size of this, double click it, and let's say I made this smaller and moved it down a little bit, let's now take a look at what's happened on the detail layer, and you can see that here the detail has also changed. The label here is in the annotation, so if we wanted to move that up, we could edit the annotation and just take this now and put it up where we might want to have it. One small but no doubt useful feature that we've added to the VAA Title Block tool is the ability to set the default symbol. Previously you weren't able to do this and you had to change the symbol after you placed the title block. So now when you select the tool, you can click the Preferences button, and where it says Choose Base Symbol, you can click there and set the default symbol that you want to appear for the file. And once you do that, then the title blocks that you place in the file from that point on will all have that particular symbol. New OZCAD Libraries, we've added a couple of additional libraries to the other ones that ship with with Vectorworks in the design series products. The first is the AS 2890.1 turning circles and maneuvering templates. You'll find these have been created so that you can place them over your driveways or turning areas, and they have transparency, so as you move them you'll actually be able to see through them and check the geometry. We have them in left and right versions, and we also have the maneuvering space here, so it's clearly set out, and we have them for the B99 and also the B85 cars as well. Here we're just showing the B99, I think it's the B85. We've also got the Anson paving hatches in the various different sizes and forms. This is just a selection of them, and you can add those to any 2D shape or to the hardscape tool and so on. Slab bounding improvements. With this feature you're now able to much more easily create slabs. These are floor slabs we're talking about, or I guess ceiling slabs as well. If we take the slab tool, you'll notice that there's a paint bucket up here, and you can now pour this into a shape, and it's automatically going to pick up the boundary of that shape and automatically associate itself with those walls. So let's place a couple of them in this space here, and having done that we'll go to say a right ISO view, and you can see that the slabs are in fact placed in here. There's one, there's the other, and because they are auto bounded, it means that if we pick up a wall and we move this wall out, the slab or slabs are going to come with it. There you can see those slabs came with the wall. So quite a useful improvement. In a similar vein, the space bounding improvements include the same functionality. So if we take the space tool, you'll notice that it now also has the paint bucket up here, and we can select that as an option for creating the space. Click inside the room and the space is going to be created in that room and auto bound to the walls that are associated with it. If we zoom in and have a bit of a look at this, you'll see that here we've got space labels that are reporting the gross and net areas in these rooms. So those numbers are actually going to change. If I move this wall, the spaces are going to come with it and the areas will change. You can see that happening in real time there. Now obviously these labels are just fairly random ones that I've chosen, but there's a variety of them. The units of these can be set obviously to round down to something that's more reasonable, either whole meters or 0.1 of a meter. Enhanced IFC. Every version of Vectorworks is going to have improvements in IFC because IFC is an evolving standard and it takes a continuous effort to keep up to date with that standard and implement the new features and also make them easier to access within Vectorworks. So looking at the features in Vectorworks 2013, firstly the dialogue has been improved and the way that you can access information is more sensibly laid out, and there are additional options in the dialogue for exporting the project to IFC. You'll also note that when you select any object that does have IFC, then at the bottom of the object info palette right down here you will be able to see the IFC category that this has been put into. So in this case this is a window, this is a wall, and you can see this now says IFC wall, IFC column, IFC door. Now on top of the fact that this is actually listed there, there's a little button at the bottom here and you can click that and this will open up the IFC information, and you can then look at that information and check that it's correct or in fact add to it. So for example, with something like a window, we could click that button and you can see the various categories here, and you may want to add something to the glazing type, for example, and you can go ahead and activate that by clicking the tick box here and then edit the value and put in the value that's there, and that's actually added to the information that was already attached to that object. Additionally, you'll find that objects in the libraries have IFC information attached to them. So here is a plumbing symbol, and you can see that it has the IFC information attached. Here's some furniture that also has IFC attached. And for those urban planners and landscape architects who have Vectorworks Designer and are working in conjunction with other architects and need to exchange their information, you'll now find support via IFC for site models, plant objects, landscape area objects, existing trees, hardscapes, massing models, and so on. One final thing I wanted to mention was that when you have an IFC object selected and you see the information at the bottom here, not everyone is using IFC, and if you want to turn this off so that it doesn't clutter up the object info palette, there is a control at the top of the object info palette you can click on that has a few other settings in it, and the new ones are show IFC data and do not show IFC data. And if you choose the second one, then this information won't appear at the bottom.